Good day, everybody. Today we will talk about lesson 7.3, apply Pythagorean theorem to solve problems. We will use the Pythagorean theorem to solve some problems in our real life or new problem which will not mention to the Pythagorean theorem, but we will find it by ourselves. Okay? Okay. So, if I have a shape like this, its base in the shape of a rectangle, and I want to know its diagonal. So I will use Pythagorean theorem. How? Rectangle here, to get its diagonal, we know that lengths and widths are perpendicular. Lengths, widths are perpendicular. So this is the length and this is the width. So to get the diagonal, it's considered here as in the right angle triangle as the hypotenuse. So diagonal here equal hypotenuse. Yes? In this case, we know the length and the width, which is the two legs, leg 1 and leg 2. So it's easy to find the length of the diagonal, which is equal at least at last 28 to the power 2 plus 21 to the power 2. So after we apply it, we can get the diagonal, which is 35. So he didn't mention to Pythagorean theorem, but we consider it after we found the right angle triangle. So we search for the right angle triangle. Okay. So our main purpose today is to use the Pythagorean theorem and its converse and apply it over some shapes or over our real life. So if I, like this example, if I have a cuboid like this one, it's based in the shape of rectangle, and it has a height, which is x, and it has length, which is a, and width, which is b, and I need to find the longest distance that I can put inside this cuboid. The longest actually it will take it from the up vertex to the most vertex. This is considered the longest way inside this cuboid. And to find it by using Pythagorean theorem, we must find right angle triangle. In this case, this slide is perpendicular to the diagonal of the last rectangle. So the rectangle of the base has a diagonal. This diagonal considered as a leg. We can say leg 1, and the height is leg 2. So in this case, I can get the diagonal D. Let's apply it over some example. What is the length of the diagonal D of a rectangle with length 19 feet and width 17 feet? So, this is a rectangle. It's better to draw it to easy imagine how to solve. Its length is 19 and width is 17, and we need to find the diagonal. In this case, this diagonal will be considered as the hypotenuse. So it's easy to square both legs. So it's 19 square plus 17 square, which is equal a number here, which is equal 361, and 17 to the power 2 equals 289. Both after we add them equal 650, and after we take the square root to both sides, it will be 25.49 maybe, so we can say it 25.5. Okay, so this is how to solve a problem like this. By taking another example of how to apply the Pythagorean theorem. If I have a cuboid, as we said before, Alex has a column aquarium with rectangular base that has a height of 66 inch. So this is the height, and length of 10 and width of 14.5 inch. What is the longest piece of choya wood that Alex can buy to fit in his tank? As we said before, the longest way, or the longest side, the longest distance inside the aquarium or inside the cuboid is the diagonal between the first vertex and the most vertex. This is considered as, we will consider it as a hypotenuse. Where is its legs? The first leg is the height, and the second is the diagonal of the base. Base here in the shape of rectangle. So its diagonal, I can get it by Pythagorean theorem. Its length equal 14.5 and width equal 10, as you see here. So if we calculate it, we can find D, which is the leg 2. So we can say leg 1, leg 2. Okay? To find leg 1, which is D, it will be 10 to the power 2 plus 14 to the power 2. After we add, we get D. From this, we will substitute in this triangle, which has his first leg is 66, second leg is what we get now, 17.6. We will take power 2 and the sum of both of them to get the Pythagorean theorem to get C, which is the longest choya wood, or the longest way distance inside the cuboid. So by using Pythagorean theorem, we will find it 68.3. Okay? Next. Also, as an apply of Pythagorean theorem over real life, we can take this example. This example is we will use the converse of Pythagorean theorem. Sandra bought a triangular shelf to hang in the corner of her room. Will this shelf fit in the 90-degree corner? Actually, always our corners inside our rules in the shape of 90 degree. This is the corner. So do you think this shelf is a 90 degree, will fit a 90-degree corner? Actually, to prove it, I have to prove that this shelf has a right angle triangle. I need to prove that this angle is right angle triangle, is a right angle. To prove it, we will use the converse of Pythagorean theorem. We have the hypotenuse and the other two legs. Use the Pythagorean theorem, and if the left hand side equal right hand side, so it's right angle, and that's what happened here. 30 to the power 2 equal 18 to the power 2 plus 24 to the power 2. After calculation, we found that 900 equal 900, left hand side equal right hand side, so this shelf is fit the 90-degree angle. Okay? The right one, this pyramid, we will consider it as a tent. A company wants to rent a tent that has a height of at least 10 feet for an outdoor show. Should they rent the tent shown at the right, do you think it's fit to them or suitable for them? Okay, let's calculate it. I need to know the height actually. And I know this side, which is considered as hypotenuse. And the base exactly will be half the real base of the triangle, of the pyramid. So I will consider leg 2 equal 12, leg 1 equal 15, so I can get the height. By using Pythagorean theorem, height to the power 2 equal 12 to the power 2 plus 15, sorry, here is not plus because it's one of the legs. So it should be the hypotenuse to the power 2 minus one of the legs, which is 12 to the power 2, equal 225 minus 144 equals 81. So h power 2 equal 81 by taking square root to both sides. H will equal 9 feet. So do you think it's suitable for this company to rent? No, because they need at least height 10 feet, and this is less than 10. So it's not suitable for them, okay? Okay, this is the lesson of today. I hope you enjoy it, and I hope you solve all the homework. Homework will be the exercises, so do your best. See you. Bye.